This is question 1 of the acid-base problems that are on the worksheet. So question 1. This question is about acetyl salicylic acid, which is the ingredient in aspirin, which is a pain reliever. So acetyl salicylic acid, which has a molecular formula of HC9H7O4. So this question is going to ask about the molar mass. It's going to ask for a concentration in the end. So we might as well just start by writing down the molar masses and atomic masses of these elements that are in this particular compound. And if we write it, we can find the molar mass really quickly. We can see that there are 9 carbons, so 9 times 12.01 equals 108.1. And then we have 4 times 15.99, which is oxygen. If we're oxygen, right, is then 63.96. And then we have hydrogen, and it is going to be, this is a little tricky, there's 7 and 8, so 8 times 1.01, which is then 808.08. If you add these together, you get 180.13 grams per mole. The question tells us that we're using 2 extra strength aspirin tablets. And an extra strength aspirin tablet has 500 milligrams of acetyl salicylic acid in it. We're going to do that times 2. So that's 1,000 milligrams or 1 gram. And the question then tells us that we need to dissolve it in 125 cubic centimeters of water. So the first thing we need, we need that in 125 CM3 H2O. We can just write that there to remind ourselves later. So first thing we need to do is we need to find the molar concentration. And the first thing you have to do that is to divide by the molar mass to find the number of moles. So 1 gram of HC9H7O4, right? 1 mole divided of the same stuff divided by 180.13 grams from over here. And that'll give us then 5.55 times 10 to the minus 3 mole of this stuff, which I'm going to now start calling HA sal, because that'll make it easier for us to write this. So we have 5.5 times 10 to the minus 3 moles of HA sal, or acetyl salicylic acid, which we're going to dissolve in 125 cubic centimeters. Now, if we take 125 cubic centimeters and we leave it as cubic centimeters, it's fine, we could do that, but in this case, I'm going to divide it by 1,000 cubic centimeters for 1 dm3, 1 liter, which gives me 0.125 liters. So our actual concentration is then going to be 5.55 times 10 to the minus 3 moles over 0.125 dm3, which gives us a 4.44 times 10 to the minus 2 molar solution of HA sal. We need to take this value and we need to put it into the ice box in order to determine the pH using the Ka. which is also stated in the question. So we can write the Ka if we want to now. Write the Ka for this acid, acetyl salicylic acid, is equal to 3.3 times 10 to the minus 4. So, icebox. We can rewrite this, of course, as, right, we can write HA sal dissociates reversibly to form H plus A minus sal. We put it in the box, right? And when we're in the box, then we have the ice. And we'll rewrite this as a decimal. Like so. We don't know this. We assume that we're just putting it in there for the first time. It hasn't reached equilibrium. So the change that has to occur to reach equilibrium is that this concentration must decrease, this one must increase, and this one must increase. Fair enough. And so the final equilibrium concentrations can be rewritten as an equation or as an expressions here, like so. And then we rewrite this and we put it into the Ka. So the Ka comes down now, right? And so we have 3.3 times 10 to the minus 4 equals x squared, right? Products over reactants divided by 0.0444 minus x. Now we're going to use the simplification because in this case, even though the difference between the two is not 0.4, I think the answer is going to be fine anyway. So we have to rewrite this then. And if we assume that this is very small compared to this value, right, that value, this x, whatever solution that x is not going to change this significantly. And if we make that assumption, then we can rewrite and put this as 3.3 times 10 to the minus 4 times 0.0444 equals x squared. And we can take the square root of each side to solve for x, and x equals 3.83 times 10 to the minus 3. If we take the minus log of that, it equals 2.42. So the pH is 2.42 for question number 1.